a couple of demos with respect to how to deploy a small, simple Hello. So yeah, just to summarize, so these are the various features and which are more popular in Kubernetes, primarily auto scaling, the service discovery. So typically in a service discovery mode, the Kubernetes will it is possible to have an enterprise-wise. There could be one Kubernetes that could be used most probably for all. You can create a lot of clusters if required, or a lot of nodes. So that is what is a service discovery is, so that you can see what services are running on which port and other things. So that is what is service discovery. And we also saw load balancing. I think in the demo also we saw where, if you remember, we exposed the service on a load balancer so that we could access the particular endpoint or a load balancer IP. So yeah, it's basically you can do all the popular, all the advanced load balancing features, all you can apply. And you can all set all the various rules with regard to load balancing. So Kubernetes will give will perfectly do a load balancer. Of course, behind the scenes, it will Kubernetes doesn't specify how a load balancer should be, because it is either you can use an on-premise load balancer or you can integrate an on-premise load balancer, or you can use a cloud load balancer. But as such, Kubernetes doesn't tell, or it doesn't come with its own load balancer. So you have to most probably you'll have to integrate with your own load balancer. But it has all the buttons which are required to talk to any load balancer that you integrate. And self-healing. So I think this also we saw a demo the last session. So it is, if there's any service which is down for whatever be the reason, so this Kubernetes will help you to auto heal itself in terms of bringing that node back if the node is down, or bring the pod back if the pod is down. So that that basic auto healing features are all inbuilt in Kubernetes. And also automated rollouts and rollbacks. This also we saw in the demo, where we could deploy at any given time a rollout at any given time, which is it's just one line command where you can deploy your latest release. Let's say you have 001, which is already in production, and you want to go to 002. So it is just one command line where you can move to 002. But in case if there is any issues in 002, we want to roll back to 001. So that is also again one simple command line. So yeah, so that advantage is all there. Otherwise, if you imagine that this automated rollback is not there, the olden ways of doing it is deploy your old binary, and of course take a backup of your binary, old binary, deploy your new binary, and if that fails, again deploy your old binary. So it's all a lot of manual work in terms of copy pasting stuff. But Kubernetes is just one command line, so the chance of making mistakes are a bit lesser, and the effort is also, and also it is very fast in terms of rolling back. It is just a switch. And yeah, the next one is service topology. So you can complete some of the microservices will have a lot of hierarchies when an end-to-end service. If you want to see what are the various microservices are being listed to complete this one service, or one service calling other service, other service calling other service. So there's a lot of chain of services that could be there. So you want to see a complete hierarchy. Kubernetes provides a complete hierarchy of topology of various services. Is very, very important, especially when you have a lot of microservices that are getting deployed. So it is really difficult to track the flow of services. So what Kubernetes will give you is complete topology of that. Next is storage orchestration. This is a very new feature which was introduced. Kubernetes till version 1.14, 1.13 or 1.14, I don't remember exactly, but till that point, Kubernetes was meant to be a stateless, pure stateless deployment services. But from 1.13 or 14, they introduced they want to make Kubernetes as a persistent state, a stateful machine as well. So which means you need to persist the state. Uh, so when you have to persist the state, which what does it mean is when pod crashes so it will capture the state of the pod into a storage. So that's where your storage is very important. So that storage will ensure that it's just like your EBS volume in EC2, for example. You can associate an EBS volume to any EC2 node. So that way it's like adding an additional hard disk to your laptop. So you can take that hard disk, put it to laptop one, and if the laptop one crashes, you can move that hard disk to laptop two. Still, you could access the contents from this hard disk. The similar concept where you can associate a volume to a node, and if the pod crashes, it will persist the state of that pod to this storage, so that you can bring when a new storage is back. The new pod is back. Then it can continue from where it was last left because the data is all persisted. So that's where the storage plays an important role. And next is this secret and config management. Again, a typical life cycle from the name itself is the secret. So managing the secrets. So generally you deal with a lot of secrets in terms of your DB passwords or API tokens. So a lot of secret information generally we deal with. So instead of going for an outside vendor, outside component, Kubernetes has an inbuilt secret management where you can store all the secrets there. So, but it all comes with the default encryption, not an enhanced encryption, but it comes with the default secret concepts. So, and of course, the config management is a bit different, where you want to, it is equivalent to like a properties file, where you can store some key and value pair, so that anything you want to store specifically an application, you can store it and then retrieve it from inside a pod. So it's like an environmental variable. And then we also saw this automatic bin packaging is like it can package your binaries and deploy it anytime. So if anything crashes, you can add a new package with just quick versioning around it. And also you can push this into a container registry so that you can get this. But just by referring the container name, it can fetch the latest version. So yeah, it's really not tied with it's all tied to a name actually, which will help you to download if the particular image is not there. And batch execution, yeah. So it is you can not just single load, you can do a bulk loads of bulk executions also are possible using batch execution mode. And regarding the last one, which is the networking aspect, where IPv4 was, all the pods will come with an IP address, and also the load balancers also will come with an IP address. So there is an IP associated for everything that you deploy. So far all the cloud vendors support IPv4, and now because of IPv4 coming to an end, we were running short of IPs in the IPv4 space, so IPv6 has come, and Kubernetes supports even IPv6. So yeah, that's a summary of features that we saw. I think we also looked at the small demo. I think we also looked at in the demo primarily we created a cluster, and also we created some nodes. Okay, I think I need to quickly create that while I do this. So let me create that. Because that I think I deleted it at the end of the session. Let me quickly create. So basically, this is G-Cloud. I think we saw in the last session. So inside G-Cloud, you can look at Kubernetes engine. So inside Kubernetes engine, we have clusters. So as the first thing, you need to create a cluster. So once you create a cluster, so you have two options to select, either standard or autopilot mode. Standard is what we looked at last time. So basically this Kubernetes that we creating here is a managed Kubernetes service from Google. So it's called the GKE, Google Kubernetes Engine. So as part of this process, we first to execute to start with anything. First thing is you should create a cluster, and also you should tell I mean how many nodes. By default, 3 nodes will be there, but you can add more nodes if required. And also behind the scenes, it creates the EC2 nodes. Sorry, the virtual machines. So yeah, I'm just going with the default name cluster one, because I can have option to select either zonal or regional. Zone is like availability zone within the VMs, the nodes that are getting created, the 3 nodes that are created in this cluster are within the availability zone. But if you want more redundancy, so you can also create them in a region so that each node will be created across region. So yeah, since I'm selecting zone, because I can, there's a lot of regions you can select. I'm selecting US Central 1A, and then yeah, I will tell you what is control plane version. So when we look at this managed services in Kubernetes, there is something called master and which is also called as control plane, and also a worker node, or which is also called as a node in Topology. I'll explain when I show you the architecture. So the master is what is managed by the cloud vendors, or a master control plane is managed by cloud vendor. So here, since Google is a cloud vendor here, he's asking what should be the Kubernetes version that you want to select. So yeah, of course you can. The static and release are two options you can pick. I think I'm going to go with the release option. So, but if you go to static, the difference is it will tell you what static version that you need. Yeah. So you can go back to any older version or latest version. 1.1.18 is the latest version, which is stable right now. Of course, you can go till like 1.15. So, and the default is this. Yeah, let's stick with this. So let me create a cluster. So and this will take at least some 2 to 3 minutes. So let me see if this is started. Create. I don't know whether my mouse is working. Screen got frozen.
Pour some coffee, man. That's it.
I couldn't access anything on the bottom. 1 minute. Let me refresh it.
I think if you have a mini cube, that is much easier doing with this.
Yeah, Minikube. Yeah, we can do that. But the only thing is, you'll not be able to see the multi-node features and all. So I mean, here we create a multi-node, right? So 3 nodes will be created, and when in I mean, just for the sake of others, I think you can. Yeah, I'm using cloud, but it is not required to use cloud for Kubernetes. You can have it on a local also. For example, I have Docker desktop, and our other option is to use Minikube. So these are two options that you can pick. But the only drawback is that your laptop is, if you're running on a laptop is 1 node. So if you want a 3 node, then you'll not be able to do that in your local laptop.
Yeah. So this was 2 years ago when I tried Minikube. It never worked. So I don't know, but I mean, maybe there was So I think, yeah, you're right. Like just one node, right? Like it's just seeing, it's not, you want to see this actually. I think in Udemy, they kind of have at least two virtual machines that they install and then they run the Kubernetes over there, I think, so on the laptop, if you want to do that.
Hmm. Wow, I don't know what's happening. So I couldn't click this button. Some problem in the Google, I guess, probably. Because I could. Let me open a new session. Okay. Fine, very good. Yeah. Run one. Let me try this command line button. Let's see what it looks. Okay, now this works. Okay, now it worked. Okay. Yep. So yeah, so while it is in progress, it will take some time. So let that happen behind the scenes. So let's go back to the slides again. So I mean, as you can see here, but there you see there no this the screen is something which came. It is they're trying to promote this autopilot mode because it's something came very recently. But anyway, so this if you look at three nodes are getting spawned this process. So yeah, so you can see the ink percentage, and yeah, it takes at least 5 minutes or more. So let's come back to this slides. Let's go back to slides and then come back here. Okay. Is my screen still visible? Could see my screen?
No.
Okay. Something is happening on my machine.
Yeah.
Could see now?
Now back.
Okay. Okay.
Yes.
Okay. Right. Yeah. So in this process, actually, it is creating cluster with three nodes, and in this process, the nodes that are created. So I think there'll be a master node and there'll be worker nodes. I think what the three that we create here, all three are worker nodes, and of course the master is something which we don't have any control, which is managed by Google. So by the way, in cloud, we will not, in any cloud for that matter, we will not be able to touch or connect to the master node. It is completely managed by the cloud vendor. So either Google or Azure or whatever. So the master node is completely hidden from us. So it is completely managed by Google. In fact, the master node is the complex component to manage if you are setting up a Kubernetes cluster on your own. And that pain point is all taken care by the cloud vendors when you do it in the cloud. So that's where you get a complete control of the worker node. You can do whatever you want with the worker node. But master is completely managed by the cloud, so you'll not be able to do much there. So, but yeah, it is good because as a developer or an administrator, the most of the pain that we have will be to manage the master. So, and that is taken care completely by the cloud vendor. So, yeah, so that's the reason. I mean, the master is that's the reason it was in the screen when we trying to create this Kubernetes cluster. It was asking what is the what is the version details and all, right? So that version details is what it is actually asking for the master. So yeah, sorry. So these are yeah. So that's about the master and the worker nodes, and the worker nodes is nothing but the EC2 components that are behind the scenes. And if also remember that we saw these are some commands that we tried in the last demo. In this process, the terminologies that we need to understand is the cluster that whatever we're creating here is it's a group of nodes. The node is nothing but a particular virtual machine, which is a host that run the Kubernetes application. And inside a node, we deploy pods. Pods is nothing but a unit of it's a unit of deployment. So and a pod can contain multiple containers. I mean, it's a good practice is a pod can be by default it will be one container, but it is not required. If you see a logical reason, you can also club multiple containers as one pod. So basically, what you can think is pod is the smallest unit in Kubernetes, uh, but a pod can have one container or multiple containers. So that is what you need to remember. And replication controller. This is other terminology that we use most often. So this replication controller will ensure the availability and the scalability of your particular application. So, for example, something called there's some keywords like desired state and actual state. So the desired state is what is your requirement that you want. Like, for example, my requirement is to say I want to have 3 instances. The desired state is equal to 3. Uh, and let's say when Kubernetes is starting, it will create 3 nodes, the 3 instances. Where if let's say if one of the instances is down for some reason, Kubernetes will automatically detect that, and it will bring the new pod instead of the failed one, and will ensure that desired state is always met. And labels are nothing but key value pairs, which will help you to identify a particular pod or a service. So key, and it's just like adding metadata to a particular pod, so that you can apply an operation to a particular pod by using the labels. Because these are terms that we need to know, but I think once you see the demo, you'll understand all these things. Services are nothing but the collection of pods exposed on an endpoint. So basically, if you deploy a Helloworld application, you will be getting a URL, and once you hit the URL, that is you could access that application. So basically, what you're hitting is an endpoint, which means behind the scenes you're creating a service in Kubernetes. So yeah, let's see if cluster is created anywhere. Okay, cluster created successfully. So yeah, if you see the cluster that got created, you could see my screen, right?
Yeah.
Okay. Yeah. So when the cluster is created here, so here if you look at the version is this, and it created with 3 nodes, and that is a cluster. The certificate management of the cluster is all taken care, and the endpoint is this, and also you have other details like the automation aspect, networking aspect, the security aspect, and the features what and all are available. So all these are something that you can enable on all these things. I think we'll come back to all this. These are some advanced features that you can implement. That we can come back to this later. But yeah, if you look at here, this is the cluster details. But behind the scenes, it created 3 nodes as you see here. So if you go to the nodes, you can see those 3 nodes which are created. So these 3 nodes are nothing but the virtual machines. They all come with some CPU and memory. So out of which some of the CPUs would be automatically taken up or eaten up by Kubernetes itself, because they need to install some Kubernetes specific softwares into these nodes. So that's why you will not get the complete, even though you allocate some number, but Kubernetes itself will take up some CPU, something that you should keep in mind. Okay, so let's come back. Let's try to connect to this cluster now. So this connect. So this is the connect component. I'm just copying it. I'm using Cloud Shell. So Cloud.
We lost the
Screen.
display.
Okay. Now if we can disconnect. You could see the screen?
Yeah, now yes.
Okay. Okay, so I opened the cloud shell. So what? So this cloud, just to give the background of this cloud shell, just like any other cloud, Google also has a cloud shell. So whatever commands that, whatever things that you are doing it on the, like creating cluster and other things, whatever you're doing on the screen with some clicks, you can also do everything using command line. So this is a command line kind of a tool where you can you'll open a shell editor where you can type the commands. So yeah, I think first thing is to set your project config project. You should set this project. So every Google thing will, I mean, everything starts with the project. So you should tell what is your project. So this is my default project that will be created when you log in. Because you can create your own project also. But yeah, this is my project ID. So I'm just copying this project ID. Thing is happening. Maybe. Okay. So I copied my project ID and I'm setting it. It's asking to authorize and in authorize. Basically, it is asking permission for to give permission to this Cloud Shell editor to access the Kubernetes API. So or the Google Cloud component. Sorry. So right now we give the permission and it got connected. So and this is a project ID that we had set. So the project ID is what you see. So which means that your all the commands that you're going to execute going forward will be applied to this project ID. Because you can have multiple project IDs. So this is asking to set the project ID. So basically, in our case, we have only one project ID. So anyway, I'm just going back to this. You could still see my screen or no?
It's dropping off. Yeah.
Not off again. It's time to restart my laptop at this. Could see my screen now?
Yeah. Yes.
Okay, I just ran that cluster command, so with which we got connected to the cluster. So I think just quick recap of what we did last time. So I think we first thing is we connected to this cluster, and we ran this command, and now let's try to create a simple Helloworld application. So I'll not spend much time here because we already saw all these things. I'm just running it quickly. I'm trying to deploy a Helloworld application, and the image ID that I used is this Docker image, which I already uploaded to Docker Hub, and the version number is 0.0.1, and this got created. And I'm trying to expose. This is where I'm trying to use a load balancer. So at this point, I created a deployment. So I basically deployed my Helloworld application onto the cluster, and now I'm telling Kubernetes to expose this deployment on load balancer, and the port is 8080. Basically, I could now access this application for a IP and port. So behind the scenes, it talks to Google Cloud Load Balancer, and it will create a load balancer, and I will get an IP address. So to know my IP address, I can go back to my services module. Okay, you could still see my screen, right? Okay. yeah, so yeah, here if you see here, it is trying to create a service endpoint. It is not done yet. So once it creates successfully, you get a message saying okay. Yeah, now it's okay. And so this is my endpoint there of the load balancer. So here, if you see this is giving the information healthy. So if I access this slash helloworld, you should be able to see that helloworld service which is developed. I mean which is deployed. So here the version is V1, and here if you see here, um, screen share is gone. 1 minute. What's happening today? No. Could see my screen now.
Yeah, it's back. Yeah.
Okay. Okay. So yeah. So if you look at so this hello world is what is exposed. So on this endpoint, and this port is 8080, and my service is hello world. So when I hit this service, it is actually invoking the output of the service. It's a simple Java application which is just giving this message saying hello world whenever you hit this endpoint. And this is a machine name of the node name, just printed to show you how when I bring every time whenever the load is getting shifted to a different node, you get a different name of the node here. Probably I just want to show you this. Since it's tied back to load balancer, actually we can try refreshing it. Sometimes this node name can change. So that way, just to show that this is getting picked up by a different load balancer or different node in the behind the scenes. I'm just giving the same one every time. It should pick up. It's not changing. Probably the load is going to same node again and again. But yeah, we can control this. I mean, so basically what is happening is whenever you're hitting the service, actually the flow is first going to a load balancer, and behind the load balancer there are three nodes which are there which we created, and each node is a VM, right? So at any given time, one could be serving that request that is coming from the browser client. So the load balancer will make a call on which node at any given time should be picked up. Let me try a different. Just coming the same thing. Anyway, let's take a look at this once we try to move to a different node, and we'll come back to this. Yeah, we'll come back to this. So basically, every time when you hit this endpoint, it will try to fetch the service and take it to a particular node. So in this process, there is some get. So basically, what we deployed is just one service. So one deployment, and also we expose that on a service which is of type load balancer. So I mean, there are type is equal to load balancer. The reason is there are other types are also there in service. I think that we will come. We'll look when we look at the services more in detail. But load balancer is one type of service. So there are other types are also there. So it's important to mention this type, the load balancer. So yeah, let's look at the get information of the pods. So here, if I click this get pods, so behind the scenes, this pod is something that that got created, and this Helloworld application is having some extra information, which is a pod ID, which will be unique for every pod. So generally the service name followed by some random number, which will uh, which will which will ensure that this pod name is always unique. Then in our case, what it's telling is 1 of 1, which means one pod is running right now, and status is running, and the time it says. So in addition to that, of course, we also created deployment in this process. So let's also see the deployments. So yeah, this is one deployment that we created, and the deployment name here is Hello World REST API, and the same name is what is used here as well. And get service. So here service is this, when you're exposing this service, you're giving type as load balancer. So that's why your type here is load balancer. So just to get service, it will tell you what is the cluster IP and what is the external IP that this load balancer is using. So this is, for example, this is what the IP that you're using to access the endpoint, and 8080 is your internal, is your external port, and 32186 is the internal port of this pod. So this pod is also a kind of a deployable unit which will have an IP address. So and also it also has a port. So basically you are talking to when this got deployed, it will be deployed on some port. But with this load balancer command, we are giving the information to expose this as 8080 because yeah, you don't want to see the internal IPs, the internal ports. You want to expose only standard port which you want to expose, and you want to take the control of what port it should be exposed. So in that case, you can apply this port. So that way, even though it uses a different port behind inside, but you're exposed, or it internally does a port forwarding, and it will fetch you the output on this port that you mentioned. Yeah. So that is the meaning of this. Because this service is not your Hello World service. This is a component. It's a Kubernetes specific component that is coming, but it's not related to the Hello World service that you deployed. But yeah, I can ignore that. The Kubernetes specific component. And yeah, get events. This will give all the details about what happened behind the scenes, like complete event history of what happened behind. So it looks simple from outside, but because you just ran a couple of commands, but behind the scenes, Kubernetes is doing many things. So that complete history is all you can get from get events command. So I mean, if you just to give a quick snap from this, at this point, it created from here you can see that it's starting a kubelet, and it also created 3 nodes, the 3 nodes that we created as part of the cluster creation, and also it is basically starting kube proxy in each of this node. So this kube proxy, I think I will go into the architecture to understand what is kube proxy is. This kube proxy is the one which is actually bringing the networking component or associating the networking details to a pod, because every pod we said like it will have an IP address and also a port. So those are all networking components. So the networking information for a pod is given by the kube proxy. Again, kube proxy is a smaller is a subcomponent inside Kubernetes, and of course it creates an networking component, and also it tries to deploy your container, and also it starts a kubelet. I'll tell you what all these things. I think I'm not going into the details now. And then it tries to create the node, and also it's basically doing the same thing in all the 3 nodes. So that's why it's repeating. So kube proxy stuff, like that, it does it and all. And once all the nodes are ready, and the queue and all the nodes are deployed with all the details of Kubernetes, like kube proxy is one component, deploying pod is another component. Likewise, it deploys a lot of information inside the nodes. Once all that is all set, then Now the master and the nodes can talk to each other. So that's when the deployment process will come. So and you're telling to deploy your Helloworld application, and it couldn't find that image, so it tries to pull it from the Docker Hub, and then it tries to create the container Helloworld, and then we also expose a service, a load balancer service, and it is and that is also scaled up to one, because we didn't mention any instances how many we need. So if you don't mention, by default is one. So by default it's scaled up to one instance. So let's go further. So this is events, and then replica set. Replica set, how many replicas? We have only one replica, so only one should be visible, because we didn't mention any replica, how many instances we need. So every time you say replica, it also gives two things. One is desired and the current. So the desired is what is your requirement, how many instances you need, and the current is what is actual current state. So this replica set's job is to ensure that the desired is equal to current. So that is what that is the goal of this replica set. So if something goes down, it will try to match your desired back. So it will try to do its level best to match your desired desired count is met. Okay, so let's now try to increase this instances of replicas from the default 1 to 3. Okay, so we increase the replicas to 3, and it says it's scaled. So if I look at this pod count again, it should be now, instead of 1, it should be 3 now. If you look at, it's very quick. So we just run the command, it instantly increases the instances to 3. And if you see here earlier, the output is 1. When we did the same thing, it had only 1. And now the same get pods is now fetching us 3. And if I go to replica set again, it should have, oops, sorry. Okay, so the status is the desired is 3 and the current is also 3. So let's go further. I think now let's try to delete a particular pod and see what is the count. So basically 3 are running. Actually, I'm trying to bring the current from 3 to 2 by deleting one pod. So for that, let me pods. You just need a pod ID to delete. So delete pod. I want just remember this GT. GT is what I am trying to delete. Something very weird would pop it. Okay. Yeah, I'm trying to delete this pod, which is pod deleted. So if I try to execute the same command, it should not have the GT that we deleted. So if you see, GT is not there in this list. So it immediately created the pod. So yeah, so one thing that we need to keep in mind is the pod is always ephemeral. So which means pod can die down anytime. So but so yeah, so that's why it is important to yeah. So that's why the service makes a very important role. The service will ensure that you get an IP address with a load balancer. So behind the scenes, it talks to these 3 pods behind a load balancer. Behind the scenes, any pod can die, but still the load is managed by the Kubernetes, and it will try to bring up a new pod. So even though that's why these IP addresses that are associated to pod, we should not tie back anything to the IP addresses of the pod. So we should always use load balancer at the front, because the pods can die down anytime. So internal IP addresses of pods shouldn't be used for any of your development purposes, because they can die down anytime, and IP can change when it comes back. So yeah, so again, so that is probably I'll show you what is the what is the command where you can also look at minus okay. So you can try this minus O wide, which will give you more information about your pod. This get pods is giving basic information, but minus O wide will fetch you more information. If you look at here, every pod has a unique IP address also. So that's why this every time you delete a pod, you get a new pod, and the IP address also can change. So that's why it is important not to design anything with respect to the pod's IP. So you should use a service IP only, not the pod IP. So yeah, one input which I thought we good to know. And yeah, let's come back to this. So yeah, we try to delete, and then we of course the replica set we also saw, but let's quickly run the replica set as well. It should be 3. And now let's try. I think we deleted that and we saw that. So yeah, I think the next scenario that we saw is primarily looking at how to increase the load. So let's say you're given a requirement to increase the load, but again, you don't want to monitor. I mean, the requirement is given to use your service will become super popular over the weekend and so many will expect a lot of hits. So in that case, you don't want to manually monitor and increase the instances. So you want to automate that as well. So basically, we're talking about auto scale based on some condition. So that if you, as long as you know the condition, then you can tell Kubernetes what should be the auto scale rule. So again, it's also a command line. So you can auto scale the deployment for your service, and the condition is the max instances you want to scale up is 10 with the CPU when it reaches 70%. So basically by default it will, let's say, have 3. Let's say you have a replica is 3 in our case. So 3 instances are running right now of Helloworld, but you want to scale up to max instance of 10, but you don't have to do it right now. 3 is good, but when a lot of load is happening, the 3 is not sufficient. So we need to scale up more instances to take care of the load. So the condition for it is whenever a CPU percentage, when the load is more, then the CPU will spike up. So that's an indication that there's a more load is coming on your way. So you will increase the CPU is 70%, then you increase the node by 1. So that is what this condition says, and max is 10. So it will increase your instances till max. I don't want to show anything for this, but yeah, this is one condition that you can scale by. So based on CPU percentage. But if CPU percentage is one option, you can. A lot of other details are also there you can use, but you can go by disk size, IO, network IO. A lot of combinations are there. But yeah, this is a standard based on CPUs commonly used. So the next scenario is. Yeah, basically you want to see a release, you want to go for a deployment. So you want to increase, I mean, there's a new version that is that you want to launch. The existing version is 0.0.1, and you want to increase that or upgrade to 0.0.2 release. So with that, you can modify this. For that, you just need to ensure that the timer, which the min ready seconds, is an indicator to tell how much time a pod will wait before it creates a new one. So I'm just telling to give a smaller number, so that way you can see this in live. So I'm just going and editing here. So if you remember, this is the YAML format that the Kubernetes created. I think whatever commands that I showed is so far is a simpler version, but I think going forward we use more of YAML, and this is how YAML will look like for people who have not seen YAML before. So it's similar to your JSON, a key and value pair. Yeah, the kind is what here is deployment. Likewise, a lot of kinds are there. So deployment is one kind, service is one kind, whatever that we saw, the commands that we saw before. So yeah, it has more details. So basically, with the just command, it internally created YAML file for you. So anyway, I'm just going to this min ready seconds, and I want to change this to just setting this value to 15. So with this, I just want to, I just want to set this image to 002. I think whatever version that we had earlier was 001, which we deployed. Now I am setting this to 2. So here I'm using set image deployment, and then the existing deployment name is this, and I'm changing that this deployment to 002 release instead of 001. Okay, so this got set to 002. So if I go back to my service, or it will take some time, but I think it will reflect that it's now V2. So yeah, so it just deployed your version 2 of your image. And by the way, where is this version 2? This is already uploaded in Docker. So Docker from Docker Hub it is taking this information. Okay, so yeah, I think we saw this. It's changed the version. So I think we also we can also quickly see how to roll back to the older version. So again, so 002, I want to go back to 001. Same command. Just the release is the tag is what I am updating here. Back to V1. So that is what this rollback feature that we saw. So yeah, so in this process, we learned many things. We looked at how to create a cluster and how to create. In this process, we created 3 nodes, and also we created a deployment, and we also exposed on a load balancer before the 3 nodes, so that the load is managed. And one important thing that you need to observe here is that is this one. This time it is changed. So earlier the GT was coming. Now that was changed to KJ. So which means the load is shifted to a different node. Well, see now it's not changing this time. So it is going to a different node. And it is back to KJ. So this is something. Yeah, this is what I was trying to show before. So behind the scenes, the load balancer is playing the role of which node to send the traffic. So that is taken care automatically here. Again, if you see here, we got a different node now. So yeah, this is what I want to show you before. Yeah, so let's go back to our slides again. Any questions in this? Okay. So yeah, I think we now understood this terminology better. Cluster, nodes, and pods. And pods internally uses container. This container is what this is a container. Actually, this image is equal to this is a container image. So deployment. When you execute this command, it actually created a pod behind the scenes, and also it used this container image for creating that pod. So that's why it's container and this pod. And replication controller, we saw the desired state, which is being met. The replica set will take care of ensuring the desired state is met always. So that's what is this. And labels. Labels is the key value pairs. We didn't see the labels, but I think I'll show you the demo of the labels in the next session. Services, again, this collection of pods, I think which is the exposure and endpoint. This also we saw. So let's understand more what is happening behind the scenes, because this is the crux of Kubernetes. Of course, there are a lot of things are there, but what I showed is the common functionalities that we do on a daily basis. But if you try to understand what is happening behind the scenes, right? When you create a cluster, what is happening? So this Kubernetes cluster, as you know, it is just a group of nodes connected to a single unit. So this K is a shorter version of Kubernetes, wherever you see K, I mean 8 characters between K and S, so it's K8S. K8 stands for Kubernetes. So this the Kubernetes basically automates when you create cluster. Actually, it is trying to create a cluster with 3 nodes, and the central node that you see here is a control plane. The control plane is completely it's a control plane or master. I mean, these two terminologies. The master is the old name, I think, because of they want to avoid this master slave concept, which is very popular. But I think people want to move away from this master slave terminologies. But yeah, but still many places master node and worker node will be used. But the new name to avoid master is like control plane. So control plane or master is all same. So control plane is the one which decides, which talks to the various nodes. Um, so each node, and in this case we created 3 nodes, but in a multi-node cluster you can create any number of nodes you want. 3 is just a minimum number to start with, but you can create any number of nodes also. So that is what is happening. So when you created a cluster, it creates a control plane, and behind the scenes it also creates 3 nodes. And this control plane or master will talk to all these 3 nodes. And in each of this node, which is nothing but a virtual machine. So this virtual machine has, I don't know whether you could see this text. It has two attributes here: kubelet, and here it is Docker. So the kubelet is a smaller component which is installed inside each node, along with the Docker engine, which will be also deployed in each node. So this Docker is I think whatever we discussed Docker before is a prerequisite for Kubernetes is that. So because you need to know Docker, the Docker image is what is deployed in all these 3 nodes. So this Docker engine has to be installed in all the 3 nodes, which Kubernetes will take care. I mean, the Kubernetes master duty is to ensure that this Docker engine is also running in all the 3 nodes, and it will get that information of what is the status of each node by a kubelet. So the kubelet is basically taking all the orders from the control plane. So the kubelet is giving the status of a particular node's health to master. So that's why this kubelet also plays a very important role in a node. So yeah, coming back to this. So this Kubernetes automates the distribution and scheduling the application containers across the cluster. I mean, that is what is Kubernetes is popular for. So it automates the distribution. I mean, if you look at we are executing small commands, but behind the scenes it is all doing all this magic. It is creating a master, and it is creating a node, and also it is talking to each node and ensuring that your container image is deployed, or your pod is getting deployed on all these 3 nodes. And to run a pod, you need a Docker. So Docker is getting installed, and also a node can die at any given time. So it has to know, master should know the status of your node. So it will make use of kubelet to get that information. So all these things are running behind the scenes, which we don't see from outside. So that's why, yeah, it is important to know the internals also, so you'll appreciate the product better. Yeah, and it has, I think we discussed this control plane, which primarily the 2 components are there in Kubernetes cluster, a control plane, which is a centerpiece, which coordinates the cluster, and such as primarily it looks at components like scheduling your application into the nodes, and also maintaining the application's desired state. You are giving three instances of Helloworld has to be running. So it will ensure that master will ensure that 3 nodes are running in the desired state is always met, and also it is control plane is also taking care of scaling requirements. So and also rolling out new updates. So all these things are managed by control plane. Basically, the commands that you give, what are commands that I gave, these are all instructions to the control plane. So we are talking to control plane, but control plane is one which is internally controlling these nodes. The nodes are workers that run the application. So your application, your Helloworld pod is actually running on the respective nodes. So yeah, the control plane is what your communication point from an outside world. You're giving instructions to control plane, and that will ensure that the instructions all followed by all the nodes, which talks to this control plane. And the nodes communicate with control plane using Kubernetes API. So all these nodes, again, they communicate their health information back via kubelet, and it gives the information to Kubernetes API in the control plane. Okay, so that's about the cluster. So cluster summary is cluster has control plane, and there are nodes, and they talk to each other. And then we created deployment. What is happening in that deployment? So the deployment, when this is a deployment that we created, the kubectl create deployment. I'm talking about this command, where at this point, if you remember, we're creating a deployment, and in this process we are telling what is the image, the container image that you want to install. So that is the instruction we're giving, and that instruction is first going to your control plane, and this control plane will ensure that your pod is created with this image, and this pod is installed on the node. So that is what this step is doing. So the deployment in this case, the control plane schedules the application instances on individual nodes. So whenever you give a deployment command, it will ensure that the control plane will schedule that application in all the nodes. And the deployment controller, there's one component called deployment controller, which will continuously monitor those instances. So I mean, when something is dying, for example, we deleted a pod. So someone should monitor that this pod is deleted, and should bring up a new pod, right? So someone should monitor the state of your pod. So that is done by deployment controller. So deployment controller will continuously monitor the instances. Basically, if any node or instance goes down, the deployment controller will replace that with a new one, and that way it is achieving the self-healing feature. And also, yeah, how do you give instructions? I think we already saw it. This kubectl command is what we gave. So this kubectl is what we are talking. By giving this command, you're giving instructions to the control plane, and control plane will ensure that using the image that you gave, it is trying to deploy that image, create a pod, and deploy that pod in the image. And this process, again, the command that you gave, again, Kubernetes API is what your command is talking to. Kubernetes API is one of the important component in the control plane. So it's also called as API server or Kubernetes API. So that is where, of course, we are using command line. Of course, you can also use the APIs also. So I mean, Kubernetes also exposes the APIs for each of this deployment. It exposes the REST API. So either you can use command line, or you can also directly call the REST API of the Kubernetes API server. So, but whatever it is, your interfacing point, whenever you give a command or a REST API call, the first interfacing point is Kubernetes API server, which is installed in the master. Okay, so any questions here? I'm just we saw the demo. I think I just want to show you what is happening behind the scenes. So that is why this slide. So most of you already saw this. I'm just trying to show you what is happening behind the scenes. Any questions here? Okay. Right, and then let's look at pods and nodes. Whatever we created. Whenever we create a deployment, we are just giving the image name, which is nothing but your container image, and with using this image, it creates a pod. Pod is, as I said, pod is nothing but a group of containers. So it could be one container, or it could be many containers. So that is what it is depicted here. So this pod could be one container, or it could be a multiple container. I mean, the multiple container, the other container could be a database also, for example. That's why it is a database symbol here. So database could be also a pod, or it could be one bigger pod and a smaller pod and a database, or it could be multiple combination of stuff. So basically, a pod could be nothing but a group of containers. So Generally, for a smaller use cases, we create only one. We just use one container image for a pod. But in advanced use cases, we can club multiple container images and create one pod. But if you see, every pod will have an IP address. So every pod will have an IP address. So the IP address will be always unique for a particular pod. So you could understand what is pod and what is container image, right? So a pod is more than one container image put together is a pod. So right. So yeah, come back to this. And in a node, if you see the node is nothing but whatever the node that we saw here is a node. This node is where this pod resides. So all these pods will be inside a particular node, and this node can have more than one pods. In our sample, Helloworld is one pod, but it is let's say you want to deploy one more pod or a database, for example. So you can deploy that as another pod. Database could be another pod, and both can reside in a node. And to understand this, I mean, I'm just giving you diagrammatical view so that you can understand what is happening behind. So, yeah, any questions, please ask. I mean, this is very important to know. Unless you know these are basics, should have this picture in mind when we talk, so that it's easier to understand. Yeah, this pod, as I said, like it's the smallest unit in Kubernetes. Again, a group of one or more application containers plus shared resources. So it is pod is nothing but a group of one or more containers, as we saw, plus shared resource. Shared resources could be your storage, could be a shared resource, or a networking component could be a shared resource, or your details metadata about like how to run a container, like image or ports, etc. So those also are shared resources. So I mean, when two pods are deployed, when two containers are created as a pod, so there could be some commonalities between these two pods. For example, the database, for example, or a storage here. Database is nothing but a storage. I mean, you can create that as a storage component. So this database or storage could be commonly shared between these two pods. Could be. I mean, it's not required, but for example, it is possible to share the same database as another pod can be commonly shared between these two pods. So the shared resources play a major role when you're deploying multiple pods, multiple containers in a pod. Right, and the pods generally they share the IP address and a port space for the co-located containers. So for example, if you look at the IP address, it is associated to a pod, not to a container. So it is associated to a pod. So which means um, let's say you want to access this bigger container image. So you will use the IP of this pod colon your port of this bigger container. So that way your traffic is going to this bigger pod, and the smaller pod could be is also sharing the same IP address, but the port could be different. So for example, this could be different port. So if you want to send traffic to this port, so it will use this IP address colon the port of this smaller pod. Same thing goes for database, for example. So that's why they share the IP address, but the ports will be always unique. Yeah, this next is the node. I think node is nothing but a worker machine where which is completely managed by the control plane, which is a master. So master will give instructions to this node. So in this process, master will tell this is the image, and you will contain image, and you create a pod, and the node will create this pod, and of course it will provide the health information of this pod to the master. So basically each pod, every pod will run on a node. Basically the hierarchy is a node. Node will have multiple pods, and each pod will have multiple containers. And this is very important to understand the hierarchy. The node can have multiple pods. And you can see from this diagram itself, a node can have multiple pods. and each pod will have multiple containers. And Node has these are two components which are initially available inside a node, which is a kubelet and a container engine. Container engine is Docker here, but again, it is Docker is most commonly used. But if you want to use any other component apart from Docker, you can use that as well. But each node should have that respective container engine. For example, you can also use CRIO, CRIO. If you want to use that instead of Docker, you can use that as well. So, but Kubernetes is something which is something that we can't change. There's a Kubernetes specific component that gives the health of your node to the master. So, and this container engine is something which will help you to create these pods. Right. And if the node dies, all the pods inside the node also dies. This is very, very important to know. I mean, each node, the node can die. I mean, we created a cluster with 3 nodes. So one of the node dies, then all the pods inside that node also will die along with it. So, which means when you create a new node, there will be a new pod with a new set of IPs could be created with when a node comes back. So yeah, so that is something. That's why these are all ephemeral components. So if anything can die here. So, but the magic is that Kubernetes will ensure that self-healing is all there. So even if something node is dying, still it can bring that node back. If a pod can die, it can bring the pod back. So a new pod back. So node and pod can still die. So that is something we need to keep in mind. Yeah. So any questions here? And is it probably is it too much of information, or maybe we can change the topic also? I mean, I see a lot of people are silent. Hello.
Yes.
Yeah.
Everyone is there.
Everyone is there. Right? Okay. Okay. Yeah. So I mean, is it okay? I mean, or we can, if it is too much of info, then we can break here also. I mean, it is very important to understand this hierarchy because these are the basics of Kubernetes.
Yeah, I think it's a good idea to have a break now
Okay.
and start next week again from this point because this is the basic, right? So
Yeah.
reinforcing is always good.
Yeah. So yeah, I think we can take a break and then we can continue further. But I think well, if you don't mind, I just want to complete this slide. We'll break at this point.
Yeah.
Is it
Go
okay?
for it.
Yeah.
Yeah.
Okay. So so we saw what is node and what are pods, and since this is a logical point, I want to complete this slide also. So we also the next thing, remember we created. Of course, we created deployment. We saw deployment, and we saw the pods, and we also saw the next item is we also saw created a deployment with type as load balancer. So, but when you clicked a get service, it showed you the service details. So basically, you should know then what is service, right? So the service is nothing but these pods, if you see, whatever these are the pods which are there, and each pod is having an IP address. So, but when someone wants to call a particular pod, so he need to know the IP address of this pod. But these IP addresses are internal IP addresses. But you are not exposing this internal. You don't want to expose these internal IP addresses to an external world. So, and also other thing is the pods, as I said, they are ephemeral, they can die. So, and they can, once they come back, the IP addresses will change. So it is not a good idea to use the IP addresses of a pod because they can die and then IP addresses can change. So then how to address this problem of having a static IP address if external world wants to call you? Like when I'm trying to hit this browser, this URL, it's actually calling the Helloworld service. So I'm using a static IP here. So the IP is not changing. So every time I hit the request is going to the Helloworld service, Helloworld pod. So how to solve this problem? So because these pods or internal IPs can change. The answer for that is a load balancer or a service. So, so the service is something which is outside, a layer which is sitting outside, and this IP address of a load balancer will be always static, so it can't change. I mean, but this load balancer or a service which internally talks to the respective pods. So it will at any given time the service will know what is the latest IP addresses, and it will route the traffic to the respective pod. Out of three, yeah, the three instances are running, then it will know that the three instances of pods are running, and the traffic should be directed to one of these pods. That's the reason when you refresh, when you created three replicas, every time you refresh it, you get a new node details. So which means the traffic is getting redirected to one of the pod out of three. One three instance out of three instances, one it is going to, right? So in this, uh, in our case, there are three pods are there, and you can see that using this command. You see here the get pods. Okay, I can show you here. It's already there. So this get pods IP, if you see, there are three IPs which are generated for your pod, this Helloworld app, right? So, but when you're calling your external IP, you're using a load balancer IP. This IP, sorry, here. So when you're using the static IP, which is service load balancer service IP, the traffic is getting redirected to one of these three pods, one of these three. So that magic is happening with this service. So service, what it does is whenever you hit a service endpoint, which is nothing but this endpoint 179, and hitting this traffic to this service, the service is internally routing the traffic to one of the three pods, and one of the three pods will fetch that information back, and then user will see that information. So that magic is happening with a static IP is done by service. So basically the spots, as I said, these are all ephemeral and they can die, and also a node also can die. So every time a node or a pod dies, the IP addresses can change. But to avoid to use only single IP, which is static IP, then you should use service, and that is what is achieved with this service. Um, and uh, and also this replica set that you see here, RS. This replica set will ensure that when you say we saw that, I think the replica set, we gave this as replicas as three. This replica set will ensure that there is always three pods are there. The desired is equal to actual. So that is what is meant by this replica set. So if a pod dies, the replica set will bring a new pod, but with a new IP. So that is what this replica set will do. Will ensure that the cluster is back to a desired state via creation of new pods, and of course the new pods created might get new IPs. Um, and how do you address so this problem of having a static IP? So that is done by service. So service will provide a stable networking endpoint. That is what a service is. It will give a stable networking endpoint which is fixed to static IP. Um, and of course, it can also help you to associate DNS and a port. Basically, static IP, a DNS, and port is what is given by service. And now we can expose this endpoint to external world so that anyone can call this endpoint. But behind the scenes, it will do the magic of routing the traffic to the respective pod. But how does service know that there could be multiple pods? I mean, this is all Helloworld in our case, but there could be some other application also could be running right in the same node. It is possible that multiple pods, we saw in the slide that there are multiple pods that could be running. I mean, yeah, let's say these two are your Helloworld app, but these two are some other pods which are not related to Helloworld. So it is possible to have that. So how does service will differentiate that these two are Helloworld apps and these two are not Helloworld apps? How it will differentiate? So that is identified by labels. So labels play a major role. in every pod, it will have a label. So the labels and selectors will play a major role in terms of identifying which pod should be used for a particular service. So these labels and selectors are nothing but key value pair, nothing but, for example, app is equal to Helloworld, app is equal to Helloworld, app is equal to Helloworld. So that's how it knows that these three pods are Helloworld specific app. So whenever you're calling a service, you should also tell what is your labels, so that's how the traffic will be routed to the respective pods. So that's why labels are very important in Kubernetes world. So because that is the one which is uniquely identifying where the traffic should route by service. So without key value, it will be difficult to identify for a service. So yeah, these key value pairs are being applied. I think I will show you what probably in the next session how these labels will look like. Just to know that there are key value pairs applied on pods, and service will discover the new pods with the labels that match the selector. So with the every time whenever a new pod comes, it can have different IP, but but the label and selector, there is a label and a selector. So uh, this label will be always unique. Even though the IP address is different, the label is always unique. That's how when you call a service, you should also tell what is your selector, which is A in this case, and using the selector, it will check whether the selector is matching to which of the pods labels, and that's how it route the traffic. Yeah, I think we will stop here. Any questions?
Yeah. So one of the thing with Kubernetes is it has a huge learning curve. So don't get discouraged if you don't get everything. That is why the session is recorded. So if you follow it through, yeah, but it takes time though. That's what it is. Unlike the cloud, this is a new paradigm, but this is where the future going towards. Yeah.
Yeah. Yeah, I think it took some time for me also to understand. I think it is, but it's not difficult. I think once you understand it in this diagrammatic way, I think you can frame a picture in mind how this works. But these interns are very important because you need to know uh, uh, how internally Kubernetes is doing things. So then you will really appreciate the magic. Um, but as a developer, you need not know the internals, but it will help you to write more better YAML files because you deal with a lot of YAML files, which I will show in the next session. So this YAML has a tree structure. So unless you understand the what is label selectors and what is replica set deployment, these are some terminologies that you need to know. Then you'll understand this why this hierarchy structure is there in YAML. So then you appreciate the YAML structure. So yeah, that's why I'm taking you in a different route. And most of um, the online sessions they directly start with YAML, but I took a different route because it took for me to understand these concepts. So I'm trying to teach you in a different way so that you understand this better. So yeah, I think we'll strategically break here. So unless you have any other questions.
Yeah. Thanks, Shah. Yeah. Appreciate it. Yeah. If possible, get back with the questions in the email so that way we could clarify things, slow down a bit, explain the basics and so on. But participation is important. That's what it is. Okay. Thanks.
So Sham,
Yeah.
do you have the slides also shared? I mean, I know the video is getting shared, but do you have the slides also shared somewhere? No.
No, actually, I was uploading into a common Google Drive, but off late I'm not doing it. So probably I will upload the share slides.
Okay. Yeah.
Yeah.
Yeah. We covered a lot of ground today, I think, but I think it's two means like
Yeah.
just to get the previous sessions were very interactive. I think today it's like a little
No, this
high
is
level.
going to be like this going forward. The more the deep dive, it's more the peeling onions. It's more we cry. But one thing is, this is the future. So if you want to build on this is going to give you a very good foundation. That's what it is.
Yeah. I think the last session was interesting because we saw the vanilla stuff, but I think now we're going a bit deeper inside this. So I think I think, but once this is basics, I think once you understand this, I think you can slowly get to know more about Kubernetes. I think these are all basics. I mean, whatever is looking at is all basics. So, but there are a lot of advanced concepts are there which are coming up next. So, but
So
foundation is
Jnanesh,
this.
yeah. So Jnanesh and the crew, my recommendation is this might be a good opportunity for you guys to get into hands-on. Even Minikube with a new laptop with the Docker Hub, you have Minikube. You don't need to have access to cloud and so on. So this is a deep tour from our cloud journey. But Kubernetes is, if you want to learn Kubernetes, you have to do it. Then only you can learn it. All these sessions are good, but if you really want to go in the little deep dive, you have to start doing it. That's it. It's a good opportunity. Try it out, and then you can ask more questions. We can slow down and we can address your questions and so on. Okay. So whoever wants to get deep dive, this is a good opportunity to start along with it.
Yeah. Of course, I mean, just to,
Okay. Thanks, guys.
Minikube is
Yeah.
one option, but we can also use Docker Duster, which I think is more promising, especially in Windows. Most of our operating systems are Windows. Docker Desktop is really good. It gives Docker and also Kubernetes. So what I see is Minikube is an external component which is also most commonly used. But I think with Docker Desktop coming into the picture. Now this is what is more effectively used now. So of course it comes with your Kubernetes component inbuilt. So but the only drawback is that you could create only one node because your laptop when you're running it, you can Kubernetes there will be master and your laptop is a node. So it is only possible to do one node, but you can't see a get pods. If you see we are seeing 3 pods, right? But it is not possible to see that kind of input, that kind of output because get pods will always show you one node, not 3 or more, for example. Yeah. So that's one thing. I will here if you have here, I think in the settings you can Kubernetes component is there here. You just need to enable Kubernetes and you can run this and Docker also should be running and Kubernetes also should be running. I think I need to. I think right now it's not started, but I think I need to start this so that way I can
Yeah. Probably
run what.
next session, if you can take this route, probably a good idea, so that this might give the people opportunity to do the local development, right?
Yeah. I can do that. Yeah. Okay, guys.
Yeah,
Right then.
sounds good, guys. Yeah, thank you.
Yeah. Bye.
Bye.
Right. Thanks, yeah.
Thank you.
Thank you. Bye.